Hey guys, good evening, all of you. I'm audible.
Good evening, Law.
Okay,
Good
good.
evening, Law.
Okay, good evening. All good. Now, so guys, we have done with the spine tree protocol, right? And what is the use of STP? Loop free.
To avoid layer 2 loops with redundancy.
Exactly right. To prevent the loop. But guys, do you know what happened? If you see, a spanning tree is preventing the loop. I'm not denying it's bad, but do you know, if you have a topology like this, take example, switch one and switch two over there, right? And between the switch one and switch two, we have a multiple links. Take example, we have a one link over there or 10 Mbps. We have another link, we have a 10 Mbps. We have
Milo,
another.
can you reshare your screen? I am seeing somewhat EHGRP event content
Yeah,
file.
law.
Strike.
That's perfect.
Yeah, fine.
Okay, now we are link number 4 over there. So we have basically four links over there. The link number 1, link number 2, link number 3, and link number 4. So we can make it this guy's a 0/0. We can make it this 0/1, 0/2 now, and 0/3, right? So we have these are the interfaces we have over there, right? Now understand the same thing we have on this side. Perfect. Now this is the switch 1 and switch 2. And why we have to the this these are my 10 Mbps links, so we can say that this is the 10 Mbps, right? So this is also 10 Mbps. This one is also, and this one is also, right? And why we took the 10 Mbps link? To provide the separate bandwidth, right? Or we can say separate 10 Mbps link for the each user. So we have a particular user out there, we have some customer, right? And we want to provide the separate 10 Mbps link to this customer. These are our requirement. I'll do one thing, I'll just draw over there. So these are my customer, and this customer need a separate 10 Mbps link. Double one, third, and fourth, right? So we have these are the four user we have behind the switch one, and I need to provide the separate 10 Mbps connection to the each user, this side as well as. So this is the PC number 1, right? PC number 2, PC number 3, PC number 4, the PC number 5, PC number 6, PC number 7, PC number 8 over there. And now I provide the connectivity through the Ethernet media to this guy as well as, this guy as well as, and this guy as well as, right? Here same we have this guy, we have this guy, and this guy. Understand over there what happened. By default, spanning tree is running on every switchboard interface, right? By default, spanning tree is running on every switch interface. Right? So it means that, take example, if this guy will become the root bridge, right? Just take example, if this guy will become the root bridge, what happened? This guy will become the non-root bridge, of course, right? So in this case, what happened? Whatever the root bridge we have, this all this port will become the DP, right? This will be a DP, this will be a DP, this will be a DP designated port, and this will be also DP. This will become the RP, and this will become the blocking one, right? This will become the blocking one, and this will also become the blocking one. So these are the, like, blocking ports we have. So now understand this link over there. What happened? I use the separate 10 Mbps link for this customer, right? For this customer to this customer, we have a separate 10 Mbps. For this customer to this customer, we have a separate 10 Mbps. For this customer to this customer, we have a separate 10 Mbps. And for this customer to this customer, we have a separate 10 Mbps. But just because of the spanning tree protocol, what happened? Just because of the spanning tree protocol, my all these three links will be downstate. Not we can say the downstate, blocking state. And what is the role of blocking port? If you remember that the role of the blocking port, right? Blocking port only receive BPD. They cannot send and receive data traffic and not learn the MAC address. And this is just happen why? Just because of the redundancy, right? You have multiple links over there, and because of the redundancy, what happened? My all these links is a blocking state. Are you getting my point? What I'm saying that now are this guy will get the separate bandwidth over there? No. Now all this person, right? Whatever the user over there, we have this site. All this user will send our traffic to this guy. All my traffic will follow by which path? 10 Mbps. So can we say like this, right? Hypothetically, we can say that this guy now is 25 or 2.5, and this guy's a 2.5, this guy's a 2.5, and this guy's a 2.5 Mbps. So are you able to utilize this particular link? No. Are you able to utilize this particular? No. Are you able to utilize this particular link? No. So it's totally wastage of the resources. It's totally wastage of the resource, and this is just happened because of the spanning tree protocol. Because what a spanning tree is going to do, it prevent the loop, and spanning tree is also important. Okay, if I'm going to disable the spanning tree, then all will become the forwarding state. Okay, understand this part. If I'm going to disable the spanning tree, then it's perfect. But what happened if you're setting the broadcast packet? Then loop will be occur. So to disable the spanning tree protocol, it's not a good solution. To disable the spanning tree protocol, it's not a good solution, right? Because if I'm going to disable the spanning tree, and if the broadcast packet is coming, loop will be occur, and this loop will be infinite loop, right? Because on the layer 2 segment, we don't have any concept of TTL. So what is a good solution we have? The solution we have, we can aggregate this particular link, right? We can aggregate this particular link. After aggregating this particular link, what happened? Now you have a my logical topology look like this: switch 1, switch 2, right? And we have a logical topology. And this logical topology, we have a switch 1, switch 2, will we have a 40 Mbps link. So all this 10, 10, 10, 10, 10 will add it, and it will become a 40 Mbps over there. So this is my physical topology, right? This is my physical topology, and this is my logical topology. And how do I make this guy as a logical topology? By aggregating, right? By aggregating the all physical link into one logical link, and that logical link is known as port channel. Why I'm going to call this guy as a port channel? Because port means what? Port means our interface, right? Port means what? Our interface. Channel means what? A path. Through that, I can send my data traffic. By aggregating all this physical link, I'm going to convert into the one logical link, and this is my logical link. And this logical link is known as a port channel. And each port channel, right, has some identifier. And that identifier is called as port ID. So we can assign that I have created this, I have aggregated this logical, this physical link into the one logical link. So I will assign this ID. So I'll assign the ID of this guy will be, take example, any random number. I can make this guy's of 10. So this will be a interface. We have port channel 10. Same thing, we have an interface port channel 10. You can define any number. It's up to you right now. We have some range. I'll let you know the range of that. But we can aggregate this physical link into the one logical link, and that process is known as a port channel. This guy is also called as a port channel, is also known as ether channel, right? Why I'm going to call this guy as ether channel? Because we are aggregating the Ethernet technology, right? It can be a fast Ethernet, it can be a gig Ethernet, it can be a 10 gig, it can be a 100 gig, or it can be a only Ethernet. So this mechanism, you are only going to apply the aggregating the physical link, you are only going to apply on this particular technology. It's not like that you can aggregate your serial link. This mechanism is only for the Ethernet technology. That's why it's called as a ether channel. This guy also called as a port bundling. Why I'm going to call port bundling? Because we are going to bundle this port, right? We are aggregating this port, that is called as a port bundling as well as. We can call out this guy as a link aggregation as well as. We are aggregating the link. You know, different depend on the like notes, depend on the docs, depend on the books, depend on the people to people, depend on the vendor by vendor. This guy has a different name, but concept is same. The concept is what I need to utilize, right? I need to utilize all this for all four link, right? By default, you cannot utilize because of the spanning tree protocol, this three link will be blocked. Only you can utilize the one single port, and that is not a good solution because all this 30 Mbps link will be besties, right? So to avoid this problem, we are going to aggregate this physical link and convert into the logical link. That logical link is known as a port channel, and each port channel has some identifier. That identifier is called as a port ID. You can define any port number. It's up to you, but they have a range. So this is the port ID I have defined, and this port will be become of the interface port channel. So for example, now if I'm going to put the one command over there, interface port channel 10, as the shutdown, what happened? I'm completely downing the all physical interface. Because in the port channel number 10, all this interface is coming 0/1, 0/2, 0/3, and 0/ right, 0/023. So if I'm going to shut down the port channel, right, logically, all my physical link will be down. If I'm going to convert switch port mode trunk, all my interface will become trunk. And now the total, all the like all this speed of this link will be added into the logical one. And now what happened? Instead of running the spanning tree on this particular link, right? Now instead of running the spanning tree on this physical link, now the spanning tree will be run on this guy. Now here the spanning tree is running. Now if this guy's spanning tree is running over there, so what happened? This guy will become the root bridge just because of the lower bridge ID. This guy will become the non-root bridge, and this will become the DP, and this will be the RP. So do we have any block put over there? No, we don't have any block put. Everything is fine now. So this is the beauty of ether channel. This is the beauty of ether channel. I'm going to run the spanning tree protocol instead of running on the physical interface. Now I'm going to run on the virtual interface. And of course, we have a single interface. One will be on the DP and another will be on the RP. To achieve this logical topology, right? To get this logical topology, we have two ways. So we can simply say that to configure the ether channel, right? To configure the ether channel, we have two ways. Channel means what? It's a path, a logical path. A road, we can say that in a simple way. This is the path interface. So we have two ways. Either we can go for the static, or either we can go for the dynamic. Of course, if you have a static, it means that you have to manually define the port channel. And if you have a dynamic, of course, we have some protocol, because always dynamic has some protocol. Like if you remember the dynamic trunk DTP protocol, dynamic routing protocol, EIGRP OSPF. So whenever the dynamic comes in the picture, we have also have a protocol, and the protocol will be PAGP, port aggregation protocol, port aggregation group protocol, right? Not only the port aggregation protocol, and the LSAP is the link aggregation control protocol. And this is the link aggregation protocol. I think so. PAGP is an port aggregation group protocol. Let me check it. No, it's for fine. Port aggregation protocol. Fine. LSAP full form. Oh, it's not given.
There it is. Link aggregation control protocol.
Yeah, perfect. Same. Now, do you know the now understand the concept of this? It's a very important one. Many person has a confusion about this part, right? Many person work in the production network and they don't know about this part. If you ask someone, hey, tell me which one is preferred, static or dynamic? See, in a dynamic, if I talk about, you have some difference over there. That's a better difference, right? That's a like uh, understandable difference. PGP is a Cisco, and this guy is IEEE. So now you understand this is the main difference, right? We have a lots of difference. This is the one of the main differences measure. Like if you have a Cisco device, you can go for the PHP protocol, and if you have a third party of the device, third party in the sense you have Juniper for any other vendor, you can go for the LSP. That's the main difference. But if somebody will ask you, hey, which one is preferred, static or dynamic? Then what will you answer? You know what people are saying that hey, dynamic is better. What do you think, guys? Which one is better according to you?
Static,
How?
I can save packets like in PA. Dynamically, we'll exchange the packets, right?
So in this case, what happened? For take example, if my neighbor goes down, then how would I know that? You know, it's totally depend on the deployment process. It's totally depend on deployment. I'm now thinking about it. What is the deployment? Think about it. What is the deployment? Okay, I'll tell you. Guys, do you know deployment in the sense of what? If your devices are there, if your device support PAGP or LSCP, go for dynamic. If your device is not support, Like, it's not like that. Listen to me carefully. It's not like that every device, every switch support the PHP, or it's not like that every device support the LSCP. You are getting my point. It's not like that every device will support the PHP, or it's not like every device will support the LSCP. Some device will support the both of them, and some device will support all the three. And some device is not going to support this guy, only support the static. On like server, most of the server, what happened? Does server understand the protocol? No, they only understand the static way. So in that case, you are going to run with the static, right? If you have a server and you are making a Ether channel, you go for the static. And in the static, we have a mode. That mode is called as a on mode. You have to configure this mode on the devices. If I talk about the PHP, in PHP we have some mode over there. One mode is called as a auto, and another is called as a desirable. If I talk about the LSCP, we have a active and we have a passive. So these are the, we have a two one. One we have active, one we have a passive. And auto we have desirable. So this is the two one, right? Active and passive. Right now, if I talk about this guy, this person and this person, both are same. This person and this person, both are same. If you understand this part, like you can understand in this way. For example, there's one guy, right? He's Amit. His name I don't know. Yeah. Right. Right. So I was talking like this is the Amit, right? And what we call over there. And take example. This is the Silpa, right? And take example, Amit has a Facebook account and Silpa also has a Facebook account, right? You can consider now this two person, like how Silpa is like your desirable, right? Or active. Good. And Amit is behave like an auto and passive. Okay. So try to understand, Amit cannot send a friend request to the Silpa. They cannot do that. They don't have ability, because auto means what? I don't have ability to initiate or to inform my neighbor, hey, let's do the Ether channel. Let's form the Ether channel. I cannot do that. So Amit cannot send a friend request to the Silpa. But here the Silpa has the ability. They can send the friend request to the Amit, or what Amit will do, of course, Amit is Amit. They will accept it and they will make a friendship and they can chat it. Got it? So what we can call over there, you know, this guy to this guy. So which one we have? And we have a system. Take example, a beautiful example we have. If this guy, we have a, in a case of PHP, I'm talking right now, auto, and this guy is also desirable, you will have a Ether channel. right? You will have a ether channel. If this guy's auto and desirable, because desirable can initiate the request, he can initiate. And he do have ability to accept it. But if I talk about same thing happened for the active as well as, right? If I talk about the auto means what? He can only accept, not initiate. So understand in this way. If, sorry. So in this way, what happened? This is the active and this is desirable. Of course, we have a ether channel because a desirable can initiate it and active can receive it, and they will form the ether channel. But if you have a take example like this one, like if this guy is now a desirable, then also we have a ether channel, right? Of course, the desirable they can initiate it and they can accept it, right? He do have ability to accept it. But take example, if you have both of them is a active and active, then sorry, auto and auto, both have, then they will not form the ether channel. They don't have ability, right? They don't have a ability. But if I talk of the same purpose in this case as well as now, copy and paste. In the case of active and passive, so if this guy is active, right, and this guy is a if this guy is a passive, they can form the ether channel. If this guy is a passive and this guy is a passive, sorry, yeah, this guy is a passive, they cannot form the ether channel. Passive cannot, right? But at the same time, if this guy is active, they can form it. If you have a two different protocol, for example, if I'm going to run with the PHP and LSCP, will it form it? Of course not. If this guy is running with the LSCP and this guy is running with the PHP, they cannot form the ether channel. If this guy is running with the LSCP or this guy is running with the on mode, they cannot do that. If this guy is running with a PHP or this guy is running with the on mode, they cannot do that. So the protocol has to be same. At the same time, you have to look the mode as well as. This is the one of the criteria, that this is the one of the criteria to get the logical topology. And on this logical topology, I'm going to run the, spanning tree protocol. But before this one, before making a ether channel, we have to follow the rules. Rules is what? The rules is something like that. Speed of the link has to be same. It means that whatever the links we have in the group, right? For example, these are the links that I have made in the group. Like take example, these are my these are my links, right? Link number 1, link number 2, link number 3, and link number 4. I make this guy, I need to make a aggregation of this particular link, right? So all the link number 1, 2, 3, 4, all they have a same speed. They have a same duplex. This guy has to be same native VLAN, same trunking protocol, same trunk allowed VLAN. These are the things that has to be seen. If these guys are any one of the difference, for example, this guy's are 10 Mbps and second is 20 Mbps, you cannot do that. First is a full duplex, second is half duplex, you cannot do that. If this guy native VLAN is 10, if this guy's a native on 20, you cannot do that. If this guy's running with the ISL, if this guy's running the 80, you cannot do that. It has to be same. Everything has to be same. Then you can form the Ether channel. First, you have to match this person, and then you have to match with the this protocol, this mode over there. Configuration wise is very easy, guys, not hard. Configuration wise is very easy, not hard. But yes, these are the rules that you have to follow. So let's keep on moving. I think so. Someone, but again, get the Ether channel. I don't. Aggregation just switching. I think so. This one. Right. So if you see that Ether channel is what you are going to only run this technology on the Ethernet media. Ethernet media is in the sense of what it could be the fast Ethernet, right? It could be the gig Ethernet, it could be the 10 gig, it can be the fast Ethernet, it can be gig Ethernet channel. So you always have to run on the Ethernet technology. Read this line. Ether channel bundle can consist up to the 8 physical ports of the same Ethernet media type. Speed media type has to be same as speed 7. See, the 8 physical port means what? In a if I talk about the PHP protocol, you can bundle the only 8 ports. Right? If I talk about the LSC protocol, you can bundle the 16 ports. But the thing is that only 8 port will be active. And 8 port will be standard. So at the end of the day, both are same. At the end of the day. Because both are giving the same output, right? So you can only up to the 8 ports you can bundle, and generally all the bundles first must belong to the same VLAN. Of course, if you used to as a trunk, I didn't mention the VLAN, I think so. Did I mention it? Not mention. Same VLAN, right? Same VLAN as a trunk. Bundle ports must be in the trunking mode. They have a same native VLAN as the pass to the same set of the VLAN, allowed VLAN. Each of the ports should have the same speed and duplex setting, and before bundle it. Of course, bundle port all must be above identical spanning tree setting. It means that at the end of the day, you have to make a everything has to be same, right? And then you can make a Ether channel. So we have already seen that two protocols are there, and there's two ways. This is the load balancing mechanism. We'll see that later on. Leave it right now. So we have a two ways. One we have a static and one we have dynamic. So in the you can use the on mode over there. In the on mode, what happened? We don't need to do the negotiation, right? We have auto and passive. That's called as a PGP and a desirable. Sorry, passive and active we have in the LSCP, right? And the auto and in the PHP we have. So the auto and passive both have the same meaning, right? What? Wait to the channel until the ask. It means that I need to just wait for it. It means if someone is requesting me, I will form it, but I cannot initiate it. Desirable active means what? I'm asking to form the Ether channel. So PHP is a Cisco developed the port channel programming protocol, right? LSCP is the IEEE standard. You can use it LSCP as well as that's it. Then we have a configuration is a very easy. I'll show you that's not a big deal. That's it. So these are the this is that we can shut down the port channel. Wait, somebody information. That's a show commands. That's it. Let me show you the configuration part. It's very easy. Now let's open this all the switch one and switch two, right? Okay, switch one and switch two. Config command, post table switch one and switch two. Enable config command, post table switch two. All done. Let me configure the IP address on this router as well as interface. Let me see do so IP interface brief. Interface 0/0 IP address brief. So now, come on, take some time to wake up the port. So I have to configure this. It is also we have a whatever the interface we have E0/0 123. All good. So what I'm going to do the first of all one thing or the interface gig 0 interface range gig 0/0 to 3. It's a recommendation to put all the ports into the shutdown state right now. Okay. Otherwise, what happened if I'm going to configure the one side as a PHP or like the auto mode, another side is a desire mode, so it will send some packet, and if this guy is not going to respond it, then what happened? They will move in the error disable state. So better to do one thing, make the port into the shutdown state. It's a recommendation like they put it otherwise to just avoid the the problems. If you're not going to do that, maybe right, the interface will move in the error disable state if they are not compatible, because this is the most important part in the examination. I'll tell you why what happened in the CCI exam. If you go for the CCI examination, you know in a CCI exam, it happens with me as well. As I remember those time right now. I don't know. I was there in the examination, and I did made the mistake. Right, it was recommendation that I thought okay, my typing is very good. I could do that, right? But you know what happened on the time? Uh, in examination, what happened in the Cisco examination? Your typing, if your typing is very good, right? But still, if you put the keyboard right now, for example, S over there, if I put over there, take example, if I put the S keyword. So right now, what happened? The response time is good right now because it's my own laptop. But over there, what happened? On the system, we have a lots of routers and many things are running over there. So over there, response time is very bad. So that was my mistake, and due to that reason, what happened? My this interface has moved in the error disable state, and to resolve this thing, it took me the 20 minutes. Configuration in just a 1 minute, but to resolve all this part, it took me the 20 minutes because we have to shut down the ports, we have to reinitiate the again configuration, check it, whatever the ports I have moved in the error disable. So better to do one thing, make it shut down. And now after that, we'll say that on a switch one, switch port trunk encapsulation dot one q, switch port mode trunk. Okay, and I say the channel, right? Of course, I need to create the channel, logical channel, and the channel group will be what? It has to be sync number, right? You can define any number from this range. I say the group number one, and after that, I will say the mode, which mode I'm going to enable over there. Either I can run in the on mode. It's only a recommendation to use the on mode where where the device does not support the protocol. Either we can go with any one. I'll just go for the desirable this side. Okay, the same channel group I'm going to create over there. But here I'm going to call this guys a auto. I'm going to configure the PHP. You can configure the LSCP as well. It's up to you. So this guys are desirable, and this guy is the auto. And what happened? Automatically created. All good. And now if I want to put the no shutdown keyword over there, wait for some time. My interface has up. Wait for more time. It will show the port channel will be up as well as, because now I have bundled the links. My all links will be up. Can you see that? My link is up now, port channel. And if you see the show IP interface brief, I have a port channel over there. And now see the beauty of the show spanning tree. Now I'm going to run the spanning tree on this port, which interface? The port channel. I'm going to run the, this is the interface that is connected with the host. The switch one is the root bridge. So if you go on switch one now, show it spanning tree, it will show you that this is the root bridge now. Switch one is the root bridge, and that's why it's a designated port over there. And now if you see the another benefit, if you show what we call show interface port channel one, can you see that the benefit of this guy is what? This one. I'm going to add all the bandwidth over there. Normally, what's the bandwidth? Normally, if you see the bandwidth of the link, you can see that normal bandwidth of the link is what? 10,000, right? 1 lakh, this one, something near around. But after adding it, what happened? It will become the all good. So this is how you can configure the Ether channel. If you see now, the verification show Ether channel summary. So Ether channel summary, and you can see that the group number one that I have created, the port channel one, right? SMIS what? SMIS is going to represent a layer 2, right? UMIS is going to represent in use. So SUM is what? It's a layer 2 in use, and my protocol is PHP, and I'm going to map all this port over there. Gig 0/01, 2, and 3. And if you want to switch one as well as same information. Everything is perfect, right? So this is how we can get this logical topology after aggregating the loop. And now we have a POTMS, and now we are running with the spanning tree protocol over there. But take example, if I'm going to bundle these two links over there, what happened? I will say the group number one and group number two. So my logical topology will look like this. Understood? So this is the port channel one. I'm just using the port channel one, port channel two. So what happened? This guy in the root bridge and this guy in the non-root bridge. So this is the DP, this is the DP, and this is the RP and blocking. Of course, right? This is how the things will happen. So guys, better to use all the links in a single group. If you have a changes of the requirement, then you can do that like in a load balancing way, right? If of course you can do the load balancing, the PV, RSTP, RPVST, and MSTP as well. So you can, again, it's depend on the requirement.
Sir, what if one or two physical links goes down?
That's I'm coming to the point 1 minute. Now this is how they can create it. But again, this is my logical topology, right? This part is my totally logical topology. Am I going to send my data traffic through this one link? No. I'm not sending the data traffic is still follow the physical media, right? You cannot send the data traffic through the RF signal that is called as a wireless. You know, through the wireless, what happening is using the RF signal, and I'm sending the data. I'm not using this over there, guys. Still my data traffic will follow via this link, but which link? Like if the PC number 1 will send the data to the PC number 5, how does switch will know that which link I have to use over there? I can follow this link as well as maybe this link, maybe this link, and maybe this link. Which link? It's whenever the packet is coming to the switch, right? Ether channel load balancing mechanism. And whatever the load balancing mechanism we have, we have a source MAC, destination MAC, source and destination MAC. Right? Then we have a so basically we have a 3-1. Layer 2, based on the layer 2, we can perform the load balancing. Based on the layer 3, we can do the load balancing, and based on the layer 4, we can do the load balancing. In according to your Cisco Catalyst, most of the Catalyst switches are going to support this one. This will you can see in the data center part, the Nexus or higher end of the switches. Normally you will see the this one and this one. What is the default one? Depend on the platform, the default one will be changed, right? So if somebody will ask what is the default one, say that change it, it will change depend on the platform. So if you see the show port channel, load balance, sorry. Show ether channel. It will be changed if you go for, if you check on Cisco packet trace and an older one. I think so they have a different one. If you have a look, enable show ether channel, port channel, load balance. Source MAC. So it's depend, right? You cannot tell that this is the source MAC, source distance and IP address. It's depend on the devices and platform. We can say that. Now, if you not change it, you can change it. I'll make this guy. For example, if you not make this guy, take example. I'll say that okay, you are the guy. You are going to based you are going to guy that's going to perform the load balancing based on the layer 2. You can do that, and you can do that on layer 3. So you can use the mixture of one as well as if you want, you can do that. But take example right now, I'm just going to deploy this two guys. Okay, switch one. I'm going to say that hey, port channel load balancing will be what mechanism I'm going to use? Can I use the port number basis? No, I can only have a distance IP, distance MAC, source and distance IP, source and distance MAC, source IP and source MAC address. I can go for the take example. I said the source IP, and same information I'm going to use on the switch 2. So guys, these are the things are coming in the like suspended state. This is the just a bug of the switch. Don't worry, it's not happening in the real world or real devices. It's just a bug. Let me one thing. Because because this is the bug of JNS3 on the switches. It's not happen on the EVNG, and not it will happen on the web IOU as well as not even the Cisco packet switch. Why I want to show you on the right now the JNS3, because I want to show you the Wireshark part. That's why. So better to do one thing. Let me flap interface port channel 1, shut down. Because if I'm going to shut down port channel 1, what happened? All my physical interface will be down, right? See, all my interface is down. If I just put it on down. So let's make a no shutdown. Let's make a no shutdown. No, just wait for some time. Meanwhile, how many interface we have? We have a 0/0, 0/1, 0/2, 0/3. The fourth port we have, right? The fourth port we have. Now, and which mechanism I have used the load balancing? Shows IP address. So what do you have to do? The PC1 is sending the packet, right? That has IP address 101. And the PC it's sending the packet to the PC number 2, right? 102. So what is the binary of the IP address of this guy, the last one from the right side? The binary of the one. The binary of will be 0000005 0 2 4 5 6 5 6 7 8. This is a binary, right? And what is the binary of this guy? It should be 2. I'm just talking about this bit, the binary. Is my Ethernet comes up? Yes, it comes up. So Ether channel. So perfect. Let's do one thing. Wireshark is this interface, all these interfaces. Start capture. Start capture. Start capture. Start capture. Now, what I'm trying to say, if the PC number 1 will send the traffic, right? What is the port 01 over there? Right? And this is the 10. So I'm sending the packet from whom? PC number 1, right? This is the PC number 1 right now. This is the PC number 2. So of course, I will send the request packet, and reply will be coming from this direction, right? How many links we have? The 4 links, right? The 4 links. So we can call it 2 2. 4 values we are getting over there, right? 0 0 0 1 1 0 and 1 1. So if you just have a look, which bit I'm matching over there? 0 1. Link number 0/1. Which bit I'm matching over there? 1 0. Link number 0 2. So the request packet will go via which link? Reply packet is coming via which link? Is it? Have a look. Send the packet from here to there, PC1. Right? And if you see request packet, this is the request packet is there. 0/1, right? Ethernet 1. Can you see that? Ethernet 1. Is it visible? Ethernet 1, 0/1, request packet. Only the request is going on 1. And if you see the reply 1, The reply should be 0/2. Can you see that? Ethernet 2. Right? It's cool now. Guys, clear? Same thing. If I'm going to use, take example, I'll just change the IP address of this person now. I'll say that, hey, your IP address is now interface 0/0. IP address will be 10. Or 10, I can make it 3. 3 is fine. 3 is fine. 3, I'll use the both of them. Yes, right. It's fine. Now 3. So what is the IP address of this guy now? 3, right? What is the binding of 3? 0, 0, 0, 0, 0. The last one, 3. 0, 0, 1, and 1. Is it? Or 1 more 0? Which link I'm going to use? 2, 2. 0/3. So for the request packet, which link I'm going to use? 0/3. And for the reply, still will be 2. So in the packet, see, 3. Request, 3. Reply, still 2. So this is how the load balancing is happening, guys. It's depend on the what kind of loader. Right now I'm using the source IP. That's why I'm looking the source IP. If I change this person, hey, now I have to look up for the MAC address. So let's go on switches right now and change the MAC address over there. I say, hey, the 4th channel now, you are not going to do the source IP. Now you're going to do the source MAC. I'll leave this side is the source IP. Doesn't matter. So this guy is going to run the source MAC address, and this guy is going to run the source IP. That's not a big deal, right? We can do that. So what is the MAC address of this guy? Have a look at the R1 MAC address. Now I'm not going to look up the IP address. Doesn't matter what IP address is there. Now show interface 0/0 include BIA. This is the MAC address of this person, right? The user one. Now this guy is going to perform, the user one is going to perform the source MAC address load balancing, and this guy is still going to do the source IP address load balancing. So what is the MAC address of the, so what is the binding of this guy? 0. The binding of 0 will be 0. The binding of 0 will be 0. So my request packet will go by which link? 0, and reply packet still will be 2. Right now, because this guy is still going to use the source IP address, right? So what is the binding of 2? 1, 0, 1, 0, link number 2. So my request will be link number 0 and reply will be link number 2. So now have a look. Ping. Sorry. Link number 0. This is link number 1. Link number 0. Can you see that? Link number 0. The request packet. Link number 0 and reply 2. Is it? Right? Link number 0, reply will be 2. If it's in the packet again, ping. Repeat 1000. Which link I'm going to use? Link number 0, right? Right now, this switch one. All my traffic is in link number 0. Interface gig 0/0. Start it down. Down this interface. Now the link number 0 is not sending the packet. Which link? Link number 3. So if the one of the link goes down, right? If the one of the link goes down, then what happened? It will change the port. It's not like they will drop the packet, it will change the port over there. And if I this link comes up now, it takes some time to comes up, right? A process client is going on, right? Now see, now it's still coming over there. So it will come to the backward one. You see that now it's come to the Ethernet 0. It's come to the backward one. So it doesn't matter, right? If the link goes down, it will switch your traffic to the another of the link, and if the link comes up, the traffic come to the same position. So this is how your load balancing is going to work. Now, take example, what happened if I'm going to use the combination in the sense of what? For example, I say, hey, now you are going to use the port channel. Switch one, I'm going to say that, hey, you're going to use the source destination map, or we can say the source destination IP default. Then this guy, switch one. Now understand this, this is the logical one little bit. Switch one is going to use the source destination IP address. Switch two is going to use the source IP address. So source destination is what? Now we have to write down the both information. Source IP will be 101.1, 103 is there, and destination IP will be 101.2 is there. What is the binary of 3? The binary of 3 will be, I'm just write down this 2 digit. Of course, the binary of 1 and 2 will be 10, right? Now what I'm going to do for this one, I'm going to perform the XOR operation. Which operation? XOR operation. If you're going to use the combination of that one, then you have to use the XOR operation. XOR Wikipedia. And if you have a XOR get, if you see, if I'm going to use the 1, so what value I'm getting over there? 0. So it should be 0 over there, right? And then we have 10. So if I'm going to 10, what value I'm getting over there? 1. 01. Which link I'm going to map over there? Link number 1. So if the PC1 will send any packet, when the switch will receive the packet, right? What switch will do? It will perform the source and destination IP. It will find the binary and it will perform the XOR operation. And whatever the value I'm getting over there, I'll just check the what link value we have, 0/1. So the request packet will go by which interface? 0/1, right? And reply is still going to use the source IP address, right? Same one. Link number 2. So reply will be coming by the link number 2. That's it, right? So you send the packet. Okay. Again, some problem is happening. Let me, this is the guy, the genus has some issue, right? So let me make it again shut down because I want to show you the load balancing mechanism in the website. That's why I use this one. But normally I'm using, right? I'm used to of the web IOU. Sorry, it should be interface for channel 1. So and guys, you don't need to remember this mechanism, like how they are load balancing doing, and nobody will ask you. Don't worry. This is just a part, like in a book. This is not given. It's given, but you will not understand from the book because it's very hard. So that's why I show you, right? So you must have a like, how these things are working. If somebody will ask you, then you can explain it. But normally they will not ask you in an interview, not even like, like tell me how this guy's work interview work, right? Even the person don't know about this thing. Wait for some time, link mail comes up. Take some time. All good. We have all my links up. All perfect. Now send the packet. Which link I'm going to use? Come on, take some time because the spanning is going on. Some listening and learning is still there. So for the request packet, I'm going to perform the XOR operation, right? and I will get the 01. 01 is going to use the link number 01, right? So 01 request packet reply will be still 02 because for the reply, switch is going to use the source IP address and switch is going to use this make the source and destination IP. Now all good. So if you see the 01, right? 01, who is the 01? This is the 0 link number 0. This is the link number 1. Can you see the request packet? Request link number 1. And for the reply, link number 2. Awesome, right? So this is the how you can achieve the load balancing. And if the one of the link goes down, so it will switch all your traffic to the another of the link. And if the link comes up again, then your traffic will come to the back to the same position. Now, if I talk about, let me stop this guy. If I talk or show ether channel, if you see over there, maximum how many links you can bundle over there. And this the link ether channel I'm doing for the layer 2, you can do for the layer 3 as well as the protocol I'm going to use the 0. Sorry, PHP. So maximum we can put the 4 links over there. This is the like a limitation of the switches. Again, it's depend on the switches or platform, the maximum port you can change it. There's a command over there. I hope so it will be available over there. Port channel something commands, not this one. I think so. Interface port channel 1, port channel, not this one. Ether channel, not. Oh, use commands. Ether channel, no. Command maximum ports interface port channel maximum. The command was there. There's something called the maximum port. If you want to increase, by default is 4. You can increase it, right? But I really don't know the command of that one. I think so. I have notes of that one. And we can stick the ether channel. And we have a notes of that mismatch. That's it. That's I have not only perfect. Very bad. LSP. I'll show you the command. Hey, hey, can you hear me? Hello? Hello, am I audible? Hello?
Yes, no.
Oh, hey, I lost my light. Okay. So I was talking like by default, you can have only 4 ports you can bundle it, and it's depend on the I was telling this part. It's depend on the platform, but if you not change, you can change it. I'll show you the commands. The command is not there in the normally book, so you can follow the Cisco one. I think so. This one I can get it. Some commands are there like a maximum ports command is there like this, but again, you have to check the like a data set like which one they are going to support it over there. Okay, commands. Show me the commands. Here are the commands, man. I knew that in the last class I shown this one. Great, this guy does not have. This is also good. Give it to me. PHP. Just hey, transport. This guy also not have, I think so. Commands are normally these commands are not fine, but it has to be there in this one. What I'm expecting. It's not there. Okay, let me check the command. I can find it in this through the CLI as well as CLI. Okay, port channel, not ether channel. It's not there. Channel. Okay. PHP. Okay. Max button. So you can change the port, right? If you want, like how many ports you can bundle it, right? So again, it's depend like whatever the switches you are going to use, it's totally depend on the platform. The most important thing you need to understand what is the use of ether channel, how the spanning tree is going to be work on the ether channel, whatever the load balancing mechanism is there, and how the load balancing is working. That said, nothing else. This is the main part that you have to understand. The most important part of the ether channel is the load balancing mechanism. If you understand this part, your ether channel is very done a very effective way. If you not understand this part, then you know the ether channel, you can explain anyone, right? What is the use of ether channel, why we are using the ether channel, like what are the protocols and which way which mode we have to use, right? On our dynamic, in the dynamic we have PHP and LSP. Again, on is like, if you have a server side, you can go for the on mode. LSP max band, yes, right? Yeah, I gave the command over. So it's depend, like, which kind of technology you have. If you go for the data center part, if I talk about it, data center has something called as a VPC, virtual port channel. Again, this is a long concept, right? They have in the data center, we have an issue with the ether channel concept, right? Not issue with the ether channel. If you have a ports on the different switches, that in that case you're going to use the VPC concept, virtual port channel. Again, depend on the technology. Whenever you're going to read the detail way, you will see that most of the things are coming out there. Any questions, guys? Anyone in the ether channel?
Hello.
Yeah.
Hello. If one link goes on, suppose it's from 1.1.2 and it is E0/2. If that goes down, how it is gonna select the other link out of 3?
It will select
what
any of
basis?
the, see, according to the sub. See, I'll tell you one thing. This is the, like, like our protocol. If you have a look, our protocol is also like, people are saying the RP is a layer 3 protocol, RP is a layer 2 protocol, and RP is a layer 2.5 protocol. Most of the, like, if you go for the website Wikipedia and I've seen anything, according to the docs, how this guy is saying that, according to the Cisco is saying that, hey, it will choose the next port number. Listen to me, it will choose the next port number. I'll send you the docs, the Cisco docs. I have one, that one, the written of like this, right? Where we have 30 questions of the ether channel, and one of them question like this. Okay, maybe I'll show you over there. 1 minute. Now I have somewhere, 1 minute, let me pause the recording, because if the one of the port is goes down, according to the docs, I'm telling you, if the one of the port goes down, so what happened, it will choose, it will go for the next port number. For example, if the port number 2 goes down, it will go to the next port number 3rd. Okay, listen to me, it will go to the next port number 3rd. If the port number 3rd goes down, it will go for the next port number 4th, if you have a port number. And if you don't have a port number, then what happened, it will go for the link number 0, right? Of course, after the 3rd, what happened, we have a link number 0. And if the link number 0 goes down, then it will go to the link number 1. And if the previous link comes up, like take example, we have a, like this one, the link now, come on. Again, this is a link number 1, this is a link number 2, this is a link number 3, and this is a link number 4, right? I'm sending my data traffic right now through this link, right? Take example. According to the docs, what he's saying that if this link goes down, my traffic will switch to this guy, right? Okay, Now, what happens if this link comes up? This one, all my traffic will switch to the automatically to the this one, and this is proved, right? We have seen that. But what happened normally if this link goes down, right? If this one, it's not like that. It will only go for the link number 2. It can go for the any one of the link who is the available over there. Who is the available over there? It will go for the any of the link. And once this link comes up, automatically all my traffic will go to the back to the same. This is how that is given according to docs. But if you do the practically, in a practically what happened, it will choose the random one that we have seen, right? I saw you that if you just watch the video, I've shown that it will choose the random one. All clear?
Yeah, no, good.
But again, this is the most important part. This guy, like, I have faced this question in the one of the interview, right? He asked me, like, what happened if the right now if this link goes down and my traffic is going through the link number 2 right now, what happened if this link comes up? You know what people are saying, that still link packet will go by the link number 2. No, it's not like that. My traffic will automatically switch to the link number 1, and you can see that in the previous video, as in the just before the 5 minutes ago, I shown you in the video, right? Like if the links comes up, my all the traffic will go by the first of the link. Any other questions? I'll find it that docs where that's very important, guys. Okay, and I also send you the one link that's a BG one, read it over there, and try to find the frequently. Just go just on the Google, just go on the Google and just write on the frequently asked question for the OSPF, for the EHRP, for the spanning tree protocol, for the NAT, for the Ether channel, HSRP. At least have a look one time. I'm telling you, you will feel confident. It's a amazing, like, the Cisco is giving the amazing docs for the interview preparation. If you want to do, you can do that. Many things you will find that is not normally available in the books. All good, guys. Any other questions, anyone?
So if one link goes down, how much the speed will be? It will be our 40 Mbps or 30 Mbps?
Of course, the link will be 30 minutes, right?
Yeah.
Dropouts will be down, of course.
Okay.
All clear. Now, one quick announcement that I have to make right now.